So I should probably mention what it was in with a little more detail of what I copied over here. It's essentially the same thing that we copied from the Nano. So they gave us this outline, and the yellow is what the silk screen. So that's what's going to be printed on top of the PCB. So sort of an outline of it. And the significant things are all the holes there. And I copied over essentially the same thing. So I have the switches, and each switch is going to connect to a voltage source and a resistor, the pull down resistor, which will go back to ground. And then these lines, those are the traces. Those are the copper lines we plan out to go in the middle of to make all the connections between our devices. Like those switches have 4 pins, and these two are connected, so the power comes in. And if we're not pushing the switch, that's what was going on in this picture. If we're not pushing the switch, the power comes in and just feeds back to ground. And when the switch gets pushed, then this connection's made and it can flow this way. So that's what those 4 holes are. The power comes in, and if the switch isn't being pushed, there's no connection to this side, so it can only go through that resistor back to ground and dissipate when nothing's being done with it. But if the switch is being pushed, then there's a connection over to this side, and the signal pin here will be brought over to a digital pin on the Nano. So I need to do the same thing for, go ahead and set one of these up for the joystick. And these joystick models I have 5 pins in them. So I'm just going to grab the hole tool, which is called a pad. So when we solder them, there's a hole going through the board and then a small pad at the top where the solder can make a connection. So I have 5 connections on there. Only used 4, but there's also those joysticks I used could also be used as a button. You can push down on it and get a button, but did not use that in this project. So right here on these grid lines, to make sure everything lines up nicely, you can see it kind of tries to snap when we get close to the line. So I'm going to snap it on the line and put 5 of these right on that grid to match the sizes. On the actual device. I can delete this one. And now all the measurements I have relative to that. So I'll draw the outline of the shape around that and just put some labels in the silk screen so I know where to connect it. And I'll get and then once all those pieces are there, we'll draw the outline and move these shapes around. I guess we'll copy the switch and resistor shape to get 4 buttons, and then one joystick, and place them inside of an outline, and then make all the connections again, just like we did over here. So we've copied over the pieces, so we're done with this and this, and don't need to save that one. So we just have, now we have all our pieces. So now let's get the outline of the joystick. And like I mentioned, with those, well, I'm going to move this over, all these over, just to give us a little more room to work with. There we go. Like I mentioned, we want to be very precise with our measurements. So from carefully measuring a couple times with the calipers, I was able to determine that the bottom of that joystick, the joystick component, is exactly 3.4 millimeters below the center of that line of pins. Or in this, what we're really drawing here is the holes that those pins will go into. So I grabbed the dimension tool. I'm going to click in the center and come down and figure out where 3.4 is. So 3.429, that, whoop, too far, 3.429, right there. Whoops, I don't know where my dimension went. So now I have that marked, and I can do the same thing from the side over here, which is exactly 8.8 millimeters over from the last hole. So I'm going to click on the center here and drag over to find 8.8 millimeters. We have 8.763, and the box we draw will be an outline, so I'm going to go to 8.89, which is where it's trying to snap to be a little bit past it. And the engineers that made those pieces set it up symmetric, so it's also 8.8 millimeters from the center of this hole. So drag over and try to match that up. Oh, past it. 8.9. And now for the top side, which is exactly 31.4 millimeters above the center of the hole. And we're doing everything digital here, but we're ordering this from the factory, and we can order it once. So that old rule from carpentry does kind of apply here: the measure twice, cut once. And it's digital, so we can do lots of measurements. So we're looking for 31.4 millimeters above. Oh, escape out of that. Didn't quite leave myself enough room. So slide that down, grab the dimension tool, and it'll snap right to the center. And then I'm going to bring that up to 31.4, and I'm going to go just a little bit past it. I think I got it all. I'm not really straight anyway. There's straight. 31.496. That'll work. So now that we have the measurements marked on there, we just need to connect these lines. And in a video not too far back in the playlist, I opened Microsoft Paint and did something quick, which was in part just to make a statement here. This is not Microsoft Paint, so when we draw, like, this component had a nice square shape to it, so when we draw a rectangle, we're not stuck with that rectangle. And I'm actually going to just click and draw a random one on here. Whoops, I'm on the wrong level. Notice how it's drawing in red. So we have to watch our layers carefully. So I don't want red, because red is the top layer that's the top copper layer. I don't want to draw the box in copper. So Control Z to undo that. I want to draw the box in the silkscreen that's painted on top. So click on the silkscreen layer. Like I was saying, we're not restricted, so I'm just going to click someplace to start the rectangle, then someplace to end the rectangle, and then select it, and we have some options. So for one, I don't want to fill that in, but we can grab these corners now and drag that rectangle around until we get to the exact spot we want, which is marked with that dimension. So whenever it snaps with that dimension line in the center of our line, we know we're good. And same thing on the bottom here. I'm going to zoom in so we can see it very closely. Grab this corner and drag up until it snaps where those dimensions are both right in the center of that line. Same thing over on this side. I'll grab this corner and snap it to that dimension. And watch carefully to make sure you don't accidentally get off from this one. And now up at the top, I'll just grab that. Whoops, I think I got off a little. Drag it up right on that line. So that's the center there. And I'm clicking the middle mouse button down to drag that around and scrolling to zoom in. Yep, I did get a little bit off, so come right over. So that one's lined up. That one's lined up. That one's lined up. And if we come up here, it looks like that one's lined up. So now we have the outline of our box. The box outline of our joystick component and the positions of the holes where that will go through the PCB, so the pins on the joystick will just slide through those holes and we can apply some solder and permanently mount it on there. So we can delete these dimensions now. So I'm just going to select it and hit delete. Select it, hit delete. Select the dimension, delete it. Select the dimension and delete it. So there's the outline of that, but probably want some labels so we can confirm everything hooks up correctly. So the view we're looking at here is from the top, which that's important to note because now we're going to bring the labels over. So I'm just going to copy from this one, Control C, then Control V to paste it. And well, if we put it here, it will be hidden underneath of the board. So we want to be able to read our labels still. So I'm going to line this up with that hole and paste that there. And the labels here on the board, looking from the top down on it, would be ground, plus 5 volts, VRX, VRY, and SW for switch. That's the one that's not being used, but I'm going to leave a hole for it. We just won't make any connections to it. So if we select that, the first one was ground, we can come over here and over on the right, we can change the text that's showing there. So the first one is ground. So I'm going to pause the video and go ahead and do the rest of those. And yeah, we can change all of these because like the label here on the switch, on ours, well, we'll get to the labeling in a moment. So we have the U1, that's the component. Then our switches over in our schematic, they were labeled with keys, so we could change that here to match it. But we want the label, so like U1, and this is going to be labeled U2 for the overall component, and then ground, VCC. We want our labels to match the schematic so that we can keep track of what's going on. We want plenty of alignment, and what's on the schematic doesn't exactly match what's on the components. So I'm going to go through and adjust all the labels to make sure we have the right labels first off. So I just took a few minutes there and went through and made sure all of our labels match up exactly. So the unused hole here, I just left that not labeled since it's not going to be connected to anything in this project, and made sure all of these labels match the labels over here. So now those have the same thing as what's on the PCB board, U2 and U1 for our units. Change this to SW for switch 1. And I changed the labels to A button, B button, C button, D button. That way it matches the code documentation. And then switch 1 and R1 line up, and make sure the 2s and 3s and 4s line up on the resistors and switches. And just took a few minutes to make sure every one of the labels lines up like it should. Because we're going to order this from a factory, so we want to make sure, we want to go nice and slow, take our time, and make sure everything is exactly right before we place the order. So I'm going to go ahead and hit save, and save this project. What is this? BC. Well, I'll go ahead and I don't need to record hitting save and typing in the names and stuff, but just take your time, be very careful, make sure all your labels line up between all the different documentation, and make sure everything's exactly right. And that old rule from carpentry applies. Measure twice, cut once.